Okay, hello everyone. I hope that you are all doing well. And this week we are going to be talking a little bit about something a little bit different than before. We're going to be talking about distributed systems and distributed storage, but it's not going to be in the context of a database. We're going to be seeing we're going to cover the Hadoop distributed file system and the MapReduce framework. Okay, basically the Hadoop distributed file system is a little bit different. Before we were talking about distributed databases. And inside the databases, what we typically do is that we distribute the documents. Okay, some of the documents are going for one partition, one machine, and some other documents are going for another machine. What we're going to be doing in this week is that we're going to be taking files, huge data files. Let's assume that the files are going to be in the order of hundreds of gigabytes, or it could be terabytes. Okay, and it's one single file. You can imagine one Excel document or one Excel document, or just simple the transactions for a big company. Okay, for example, I will be saying, for example, that we can keep track of all the transactions for Amazon in one single day. You can imagine the size of those files. And typically, what we try to do is that we partition the file into pieces, and then we're going to be distributing those files into all the machines that we have. And then we use the Hadoop, the MapReduce framework, in order to process those machines. Okay, because the idea is to be able to storage the data, huge data files, and we also want to process those data files in a very efficient way, exploiting all the parallel computing and distributed systems that we have. Well, the main features of Hadoop. So basically, going to be quickly describing Hadoop, and then I will talk a little bit about the Hadoop distributed file system, and then I will talk a little bit about the MapReduce system. This is quite popular, and it was very useful, and it's quite useful. Now there is no new technology that unfortunately we don't have time to cover this semester, which is called Spark. But this is also a very popular technology in order to process big files. Okay, basically the idea of Hadoop distributed file system, and what we are going to cover in this week is that we are going to be trying to trying to process a huge data files. Okay, for example, with Mongo, okay, we have a database, and in that database we are going to have documents, and probably the size of the database is quite big, let's say a few gigabytes. And then we can split those documents into different clusters. And basically what we try to do is that we are going to move in Mongo. We try to move some of the documents to one cluster, or we partition the database into small pieces. Basically, we put one document in one computer, another document in another computer, and so on and so forth. And that's for Mongo. Now, with Hadoop, what we try to do is that we're going to process huge data files. Okay, imagine that we have one file. It could be one, for instance, it could be an Excel document or a Microsoft Office document, one single file, but it's going to be a huge file. Okay, imagine that this file is going to process all the transactions that Amazon is going to have in one single day. Okay, so that could be in the order of hundreds of gigabytes, or it could be even a terabyte. And that's something that we're going to be taking into account with the Hadoop distributed file system. So basically, I want to make this difference that with Mongo, we are going to process a database, and we are going to partition the database, and we separate documents. If we use different techniques, we can separate documents. Here, we are going to be partitioning a file. Okay, so basically individual files, but the size of the files are going to be huge, quite massive. And then we'll be seeing how we can process those files using the MapReduce framework, which in fact is going to be map, sort, and reduce. That's the idea of this. Okay, so basically the Hadoop distributed file system, the Hadoop system is just basically for processing big data files, and basically what we're going to be using is a cluster of regular machines. Okay, for example, and that's one of the main differences between supercomputing technology and the Hadoop system technology, that we are going to have a cluster of, let's say, regular computers. It could be like the processing capacity that we have one of these machines. It could be the processing capacity that we have in a regular machine. So basically, what we want to say is that anyone can build a Hadoop distributed cluster. For example, we could build a Hadoop distributed cluster using one of the labs that we have in UCC. And why we have this? Basically because these regular machines, they have, well, typically they have one of the machines, they have a low performance compared to a supercomputer, okay, but only one. Now, if we put together 1,000 regular machines, then the performance is going to be starting to be better, okay, it's going to be more robust, more important. Typically, a regular machine is going to be cheap, and we can find regular machines. It's quite easy to get one. Okay, but now if we compare this with supercomputer technology, basically the performance they have one supercomputer, they have really good performance. Okay, they are very fast. The processing units that they have is very fast. They are very expensive. Okay, getting one supercomputer. In the past, I had the opportunity to work with very good supercomputers. For example, I was working with the supercomputer of the University of Tokyo, and they are really expensive. Okay, and the cost is proportional to the number of processing units that we use, and it's really expensive, and that's really difficult to obtain. To get access to one of those supercomputers is really difficult because only a few companies can manage to get one of those because it's really difficult to build. They need a special components. But regular a Hadoop cluster with regular machines that we can build that almost in no time. Now, let me now talk a little bit about the differences between the Mongo distributed databases and Hadoop distributed file systems and the Hadoop system. Okay, one of the main differences is that in Hadoop we are going to be processing data. We are going to be processing quite a lot of data. Okay, and we are going to have doing this processing is offline. Okay, because the amount of data is huge. Okay, and then we are going to be storing this data. We are going to be processing that data. For example, let's say that we have a file, okay, and we have a set of transactions, okay, transaction one, transaction two, transaction one, and let's say the amount in euros, the cost of this transaction, let's say 100 euros, and then we have transaction two, and the amount, and transaction three, and so on and so forth. And for example, what we want to do is to get for example, the cheapest transaction or the most expensive transaction, all these kind of things. And typically, we're going to be doing all this offline. Okay, and what do I mean offline? It means that, for example, I'm collecting, for example, for Amazon, we're collecting all the transactions of Amazon in one day, and then they want to process those transactions in order to see which are, for example, the most important products for them, the ones that are that are giving more profit, and then they want to advertise those products more in the website. Okay, so basically what we do is that we try to collect all that information during the day, and then during the night, overnight, we are going to be processing that file. And typically, if we are talking, for example, in the context of Amazon, that could be hundreds of gigabytes, or it could be in the order of terabytes. Okay, so for that reason, we are going to need a few hours to process that. But depending on the information that you are storing and processing, it could be in the order of minutes. So that's the interaction that we're going to have with the Hadoop system. Now, in the context of Mongo, what we are going to be doing is that this is more online processing. Okay, we are going to be storing important amount of data, but it's not going to be as big as the amount of data that we are going to be storing with Hadoop. And remember the difference. One of the key differences that in Hadoop, we're going to be storing files. Okay, imagine one CSV file, okay, or one Excel document, or things like that in Hadoop. Okay, in Mongo we have a database, and inside the database we're going to have collections, and inside the collections we have documents. So what we do is that we separate, we partition the documents in Mongo. So one document, a set of documents are going for the first partition, the first machine, some documents going for the second machine, and so on and so forth. I will describe later on how we partition the documents in Hadoop. Okay, and typically this is something that we are going to be doing more. Let's say that the interaction with the client is going to be, let's say, real-time interaction. Okay, so for example, the customers is going to populate the database and then it's going to get information. And we are going to be doing that in the order of milliseconds or seconds. Okay, so it's quite, let's call this real-time. Typically, when we're talking about seconds, when we talk about real time, we talk about in the order of milliseconds, but let's assume that this is in seconds, mainly because what we store is in the order of gigabytes. It could be also in the order of terabytes, but typically we're not going to be using Mongo for those huge, massive uh, system processings. That's more for Hadoop, where we have huge data files. In Mongo, we have a database with documents. Okay, so basically the idea of Hadoop that started quite a long time, well, quite a long time ago. It started early in the 20s. Basically, there is one paper, one very popular paper, which is called the Google file system, and then they start talking about the MapReduce system. As far as I know, what they noticed is that they were using uh, traditional relational databases, and they reached a limit that they were using a lot of massive information, and they couldn't scale. Okay, they couldn't get information that they needed in the time that they needed. So that's why they started to think out of the box, and they start designing this new technology in order to be able to scale to that kind of information. If you Google, you can have a look at the Google file system, and you can also have a look at the first research paper about the MapReduce framework. I will be talking a little bit about the MapReduce framework. It's not really that difficult. It's just a framework in order to process these huge data files. The main system, the main features of Hadoop, basically Hadoop is going to be using clusters, okay, cluster of computers, and then in the cluster of computers, we're going to be doing both storage and processing. That's important. So basically, we have a set of machines, and the machines, all of the machines are going to be storing data and processing data. That's important. That's something important that we have to take into account. We are also going to be handling data replication, and I will be talking a little bit about this in a minute, how Mongo is going to distribute and replicate data. So basically, if there is a failure, then the system can recover itself in order to be able to deal with these situations. Basically, if a node is failing, okay, if a failure is something goes on, then we can. These are some of the main features of Hadoop with relation to failure tolerance. Okay, so basically, if for some reason one of the nodes or computers fails, then and it's not working at all, we cannot reach that computer. Let's say that it's a hardware failure or something like that. Then the system is going to be able to still process the entire data set. That's something that we have to take into account without huge penalizations. Okay, basically the system is still going to be able to work. It's still going to be able to process data. Probably the performance is going to be decreasing a little bit because okay, one machine is failing. But imagine that only one machine is failing out of 1,000 machines. So the total performance is not massive. Okay, of course, if you only have, let's say, 10 machines and one is failing, okay, well, basically the performance is going to decrease more or less 10%. But typically, we're thinking about a lot of machines that are working in parallel. So basically, it's not going to be a huge performance. And the data set is still, we are going to be able to, we can still access the data set, which is important. All the data sets, all the data that we have in the system. That's because of the structure that we use in Hadoop. And what we are going to be doing is we are going to try to move the workload of that particular node to, we're going to distribute that workload to for the other machines that are still working. And then once the machine goes back, then we redistribute again all the information. That's one of the main features of Hadoop. We can easily add new nodes. Okay, so basically, for example, if we see that, let's say that we are working with 20 machines and we see that we need more capacity, we need more power, with more processing power, then we can just increase the amount of nodes that we have. And then the nodes are going to cooperate, they share information in order to deal with the situation. Basically, well, Hadoop is actually a very popular technology, and most of the big companies, the most important companies, and also small companies, they use this technology for data processing. Okay, so now today is a very popular technology, I'm quite sure that all these companies and more, they use this technology in order to process big data files. Okay, so now I'm going to be talking a little bit about the Hadoop distributed file system, how it works. Um, Basically, the Hadoop distributed file system is going to have two main components, and we're going to be talking about that. One is for distributing files, okay, how we can allocate files or portions of the files to the different nodes, to the different machines that we have, and the other one is for processing the map reduce. So how basically one is for processing, for distributing the file, okay, for storing the file in a distributed way, and the other one is now we are going to be talking a little bit about the description of the Hadoop distributed file system. Okay, and we're going to try to compare some of the main features with Mongo that we covered last week. Okay, and basically the cluster we're going to be seeing that is quite similar actually. We're going to be seeing that in Hadoop cluster we're going to have a number of nodes. Okay, and a node is going to be a machine. We can see a node as a machine. Okay, and actually we can only if we only have one machine, we cannot have only one machine, and hopefully that machine is going to have, well, the machine must have a number of processing units. Okay, so basically that's the idea, and this is more or less how it works an actual Hadoop distributed cluster. Basically, we are going to have a set of machines, okay, and basically here we have a number of machines, here we have a number of machines, and so on and so forth. Another important component that probably you are not aware is that the cooling system is very important, okay, because all these machines they produce a lot of heat, and then we need to provide a very good cooling system. Otherwise, you might have a lot of problems, and that's something that they have to take into account. And the systems again is going to be we can have the Hadoop distributed, the Hadoop cluster. We could be in the same location, okay, something like what we have here. That we have multiple machines and they are connected in a way they are connected, or it could be in a different places. Okay, they don't have to be in the same physical location. You can have them in different countries, and then the connection is going to be, for example, using internet. Here, the connection could be using a high-speed local network. In Mongo, well, in Mongo, as we covered last week, basically we have two types of nodes. One of the nodes is going to be, we call them the sharding nodes. Okay, basically this is one partition, and then we have the primary, and then the secondary nodes. We have one primary and at least two secondary nodes for each particular sharding, sharding partition, and then we have the metadata. Okay, remember the metadata is quite important because the metadata is going to store information about the partitions. Okay, so basically, if the client wants to look for a particular document in a Mongo database, in a Mongo distributed database, basically the client is going to interact with the interface, and then the interface is going to check with the metadata about the potential location of that particular document, and then the metadata is going to reply to the interface with that information, and then it's going to look for the document in a particular sharding partition. So that's why we need to have this metadata. This is actually very important. In a Mongo, uh, in a Mongo system, distributed system, if one of the partition fails, we can still process data. But if your metadata fails, there is no way that you can interact with your system. So that's something that you have to take into account when dealing with distributed storage. Now, in the Hadoop distributed file system, the system is quite similar, just so that they use a different terminology. They have data nodes. Okay, basically in these data nodes, we're going to be storing data, portions of the data. I'm going to talk how in a minute. So basically, we have a number of data nodes, and we are going to be using those data nodes for both for storing data and for processing data. Okay, and then we have the name node. The name node is quite similar to what we have in Mongo with the metadata. Okay, the name node is the one that knows that where the data, each particular portion of the data is. Okay, so basically, as I said, this is basically similar to the metadata in Mongo. And now, when we are dealing with in Mongo, the way that they used to distribute is that we use the size of the partitions, okay, the size of the sharding we are going to be using. Basically, we can define this. So basically, we're going to be storing up to, this is a number, a parameter, but in this case, it's up to 64 megabytes of data in the documents. Okay, so basically, inside a portion, a chunk, we're going to be storing documents, and the amount of the total size of these documents is going to be 64 megabytes. This is the default configuration. Now in Hadoop, we are also going to be using a similar concept. Now they call it blocks, before they call it chunks, and we have a particular size that we are going to be doing. So basically what we're going to be doing now is that we have the file. Remember that the difference between Mongo is that in Mongo we're going to be storing collections, documents, and then we distribute the documents. And now here we have a file, and what we have to do is that we have to split this file into blocks. This is a parameter, okay? Could be something different. And the size of each particular block is going to be at most this number. Okay, imagine that you have one single file, and this is the size of the file. So now what we're going to be doing is that we're going to be splitting this into pieces, okay? So basically into pieces that are blocks that are going to be using this file, up to this file. So basically this is going to be one block, this is going to be the second block, and of course here we don't have, this is going to be the third block, which is not going to be more than the, it's going to be less than the maximum amount. And basically this is how we're going to be uh, partitioning the information in Hadoop, in a Hadoop distributed file system. And now the replication, okay, so basically this is just how we can distribute the information, how we can distribute files into my cluster. In this case, we're assuming that we need to have at least, we can have three different machines or nodes, one for this one, another one for this one, and another one for this one. But this is just an example. And now replication. Remember that replication is really important. If something fails, then we can use the other nodes. In this case, this is the case of Mongo. We can use the secondary nodes in order to recover the information. Okay, so basically this is how replication works in Mongo. Basically in Mongo, we are going to have the primary node, and we are interacting with this node. Okay, so basically when the client is going to write or read something from the database, we are dealing with the primary nodes. Here we just have we duplicate the data in the secondary nodes. So if the primary fails, we need to reconfigure everything in a way that one of the secondary nodes is going to be working as a primary. But we are not going to be dealing, we cannot use these nodes, the secondary nodes, for processing, okay? Because all the processing is going to be done in the primary. This is how we deal with uh, with uh, with Mongo. Okay, so the important here is that we have the same information in the secondary nodes, and we cannot use those. In Hadoop, the replication works also at the level of blocks. Okay, we need to have each particular block. Well, each particular block we need to duplicate. We need to create copies of that. So for each particular block, let's say that we have one block big one. Okay, we need to have two more copies of this. Okay, big one and big one. Okay, and then these three copies of the block, they must be physically in different nodes, in at least three different nodes. This is a parameter. Okay, but you can change that. But we need to have, as far as I remember, you need to have at least three different copies of each particular block. Okay, so now let's imagine that we have that huge file that we have at the very beginning. Okay, .txt, and that divide this into three pieces. Okay, block 1, block 2, and block 3. This is the partitions that we have. So basically what we're going to be doing is that we start distributing that. So basically we said that this is going to be the first copy of block 1, this is going to be the second copy of block 2. They must be in different partitions, and now we start creating the three copies of block 2. So 1, 2, 3. We still need to copy we still need to create one copy of block 1, and then we continue with the block 3. Okay, now we need to add, now we have 2 copies of of block 1 and 2 copies of block 3. We already have the 3 copies of block 2, so now we need to put the additional copy of block 3 and the additional copy of block 1. Okay, so it's really up to Mongo to decide where to locate the blocks. Okay, for example, here we could have something else. Okay, but the idea is that we are not going to have 2 blocks of the 2 copies of the same block in the same partition, in the same node. Okay, for example, here it's not ideal to have v1. Okay, this is not ideal because uh, it will be appearing in the same node. So basically, and then this is not going to be, this is not the idea. We need to have that in different nodes, because if the matching fails, we need to have we would like to still have access to that particular block. Okay, so that's the idea. And also we want to have load balancing. Okay, so basically that all the partitions, they have more or less the same amount of blocks. This is the idea of this replication. And yeah, and also something important here. Okay, so basically let's say that we have we have all these nodes. Something important and is that they are not going to have, probably or not necessarily, we are going to have the same information in the 3 nodes. Okay, that's something important, and that's one of the main differences with Mongo. In Mongo, the secondary nodes, they will have exactly the same information as the primary. Here, no. In the Hadoop distributed file system, we distribute the nodes, but we don't have we need to have we're not going to have exact copies of the information, because what we are distributing, and we replicate the blocks. Okay, and then we can start playing with that information. That's something really important. Okay, so basically this is what we are going to have. For example, here, look, this is one of the nodes, and the information that we have here is not necessarily the same as the information that we have in this other node. Okay, it's different. Okay, it could be, for example, it could be that we have B2 and B3 here, but it's not necessarily the same. We could have different information in the nodes, and that's one of the main differences with the way that we store data in in, in Mongo. Okay, so now when we are dealing with the Hadoop distributed file system, the Hadoop distributed file system is similar to another file system. Okay, for example, the file system that you have in your computer, when you have your Windows computer or your Linux computer, you have what we call a local file system. Okay, so basically they have a way in order to store in your files. Now in Hadoop, they also have their own Hadoop distributed file system, which is going to create all these partitions and is distributed. In your local file system, you have everything in one single machine. In the Hadoop distributed file system, the system is going to create all these blocks and is going to distribute that in the distributed way. Okay, so basically we need to differentiate, create this, understand the difference between your local file system, and in that local file system we are going to have the data node with the metadata, and then we have the Hadoop distributed file system that we have. And here we are going to have all the distribution and everything. Basically, what we're going to be seeing at the very end is something like this, that we have for each particular physical node or computer, we're going to have a data node in the local file system, and then the Hadoop distributed file system is going to be in the different data nodes that we have. Okay, remember that the data node is just a processing node, well, a processing and a storage node. Okay, but it's just that it's going to be distributed. The only thing is that you are not going to be, this is how it's going to be physical implementation. Okay, we are not going to be seeing that when we interact with the Hadoop distributed file system. And basically what we're going to be doing, of course, when you have your file in your own computer in Windows using a local file system, then you have to use a function add that is going to copy your file, one or more files from your local file system into the Hadoop distributed file system. And then once you call this add function, what you will be doing, then the system is going to be interacting with the name node. It's going to split the file into multiple blocks, and then it's going to distribute that into the data nodes that we have. Okay, and remember that we're going to be creating 3 copies of. So basically, what is going to happen now is that we are going to be distributing those partitions. So basically, we have block block one here, block one here, because we have the 3 different copies of the block, and then the second block again 3 times, and then the third block. Okay, basically this is what is going to happen. Now, if we want to copy to another files, it's going to be exactly the same. Okay, so basically the local file system is going to transfer that into the global file system. The global file system is going to be the name node is going to split that, and then it's going to distribute the files, creating at least 3 copies of the, the blocks that we are using. Okay, and then basically this is going to be storing the the name node is going to be storing the metadata. Okay, basically we know here that block one is in this particular node, and this particular node, and so on and so forth. This is the, the idea. And then of course we can put information there, and then we can get information. Okay, basically if we want to get information, what we have to do is that we are going to using a function that is called bring back, that is going to get information from the Hadoop distributed file system, and is going to copy that into your local file system. This is the idea. Of course, this is going to be using the name node and the metadata in order to reconstruct, to rebuild the entire file, because the file is distributed. So, and we want to move one single piece of data into the local file system. That's going to be the idea. Okay, for example, let's say that this particular node is going to want to get access to the file. So basically what this is going to be doing is that it's going to be contacting the name node in order to get that information. And then the name node is going to look for the, the particular data that we want, for example, B2, and then it's going to transfer that. And that's how it works. Now I'm going to talk about the last part of this video. Basically, the idea is that I'm going to be talking about the map reduce framework. So far, we have been seeing how to store data, how to store files in a Hadoop system, in particular using the Hadoop distributed file system. And we will be seeing how we can use the map reduce framework, which is actually 3 components: map, sort, and reduce. And I'm going to quickly cover this in a minute. Um, Basically, this is what we have been seeing so far. Basically, we have again the Hadoop distributed file system, and we will be covering the MapReduce framework. And in particular, remember that we want to focus our attention using huge data sets. Okay, we are talking about files, individual files with, let's say, hundreds of gigabytes. That's what is important. And we are also focused in a cluster of computers. Okay, we want to use a cluster of computers with an important number of machines. We don't need to have any fancy machines. It could be regular machines like the ones that we are using at this very moment. And the idea is the MapReduce framework is going to work on top of the Hadoop distributed file system. And typically, basically, a MapReduce program is just we have different alternatives in order to implement MapReduce. We can do it in Python, we can do it in Java. And there are a number of other alternatives. But that's just regular Python code or Java code, as long as you follow the structure of the framework. Follow this idea. Well, that's the general idea of the MapReduce framework. It's just basically a pipeline of processes, and we're going to be operating in multiple files. Imagine that each particular block is going to be one file. Okay, remember that we have a number of nodes. Each particular node is going to store a number of blocks, and we have a number of machines or nodes working on those blocks. So basically, we are going to be operating each particular block is going to be one file, and then we will be processing these files. Yeah, and we will be using a high-level programming language that I was mentioning before. You can do it in Python, you can do it in Java. There are multiple options. And basically, what we're going to be processing is that we're going to be processing all the files that are inside a folder, okay? And those files are going to be the data nodes. Those files are we're going to be using the data nodes in order to process those files. Ideally, for example, the first block is going to be in a particular data node, the second one, and so on and so forth. And the output as well is going to be in another Hadoop distributed uh, folder, Hadoop distributed file system folder. And then in this folder, we're going to have all the output files with the output blocks. Again, the output is also going to be a set of blocks. Most of the time, we only need a single block, but that really depends on your application. That's something that we have to take into account. And at the end, what we have to do when we are writing a MapReduce program, this is basically using the MapReduce framework. This is going to be a black box for us. Okay, we don't know how. Well, we get an intuition of what's going on inside, but we don't really need to know all the details. All we need to do is to be able to write the mappers. So basically, we need two programs. One is going to be the mappers, or for the map part, and the reducers for the reduce part. Okay, and then we are going to have the input folder. The mappers are going to be processing all the files in the input folder, in the input Hadoop distributed file system input folder, and then the reducers are going to populate the output Hadoop distributed file system folder. And we will be seeing how it works inside. But again, inside this is going to be a black box. We don't really need to know all the details of what's going on inside. We need to understand the general idea. That's important. And basically this is going to be the process, what is happening inside. We don't need to understand all the details, but we need to get a general understanding. Okay, basically first we have the map stage, a sort stage, and then a reduce stage. And it's always going to be in this particular order. First we go with the mappers, and then with the system. We don't have to do it. The system is going to sort, and then the reduce phase. This is a very popular example of a MapReduce program, the idea of the MapReduce program. Basically, the idea is that we're going to have an input file. Okay, we're going to assume that this is my input file, of course. This is just an example, and that's why we only have this tiny file. Okay, basically, this is the input file. You can see initially that this for you one single file, the quick brown fox, the fox are ate the mouse, and so on and so forth. Okay, it's a tiny file, but this is only it's only to illustrate the process of the MapReduce framework. Okay, the idea of this program is that this is going to be the input, the file, and then the output. All we want to get in the output is we want to count the frequencies of all the words. Okay, for example, brown is appearing two times, it's appearing twice, one here and one here, and then fox is appearing two times as well. So one, two. Basically, we want to count the frequencies of the words using the MapReduce framework. This is a very popular implementation of the MapReduce framework. So basically, the idea of the mappers is that first we are going to get individual words for each particular block, because initially what is going to happen, this is going to be the input file. We're going to translate that input file into the Hadoop distributed file system, and inside the Hadoop distributed file system we're going to create, well, the system is going to create blocks. For example, in this case we have 3 blocks, and then for each particular block we're going to have one mapper. Okay, so basically the mappers are always going to create key values. That's the way this works. The mappers are going to get as an input a file, and the output is a set of key values. And basically the key here is going to be the word and, let's say, the frequency in this block, for example, or we can just have repeat that information. For example, the appearing once, brown, and so on and so forth. for this mapper. For this other mapper, for example, we see that there is appearing twice. So that's why we have that particular element 2 times, and so on and so forth. Okay, so basically the input for the mappers, and these mappers, you can see that this mapper is going to be working in one particular node. Let's say that this is node 1, and this is node 2, and this is node 3. So they work in parallel. And remember that the size of the block is more or less the same. So basically, these mappers should be finishing the work more or less at the same time. And that's why we are exploiting this parallel computation and parallel and distributed computation using the MapReduce framework. So basically, these key values are going to be the input of the reducers. In the middle, we are going to have the sort phase. And sort is just going to be sorting these key values using the key. So basically, it's going to be sorting the key values. And then that's going to be the input of the reducers. And then the reducers are going to be aggregating the output of the mappers, and so on. Basically, for example, here we know that, let me just quickly delete this in order to, basically the mappers are just going to be, we process this information, for example, all the keys in a particular, for example, the brown fox, because we're going to be sorting this, they are all going to for this mapper, and the same here. Although, let's say that the first n keys are going to be for this reduce, and the other ones are going to be for this second reduce. Something important is that the sort phase is going to separate depending on the number of reducers, but all the keys, all the key values elements with the, for example, with the same key, all the elements with the same key are going to appear in the same reducer. That's something important. For example, then all the elements with the are going to be appearing in this reducer, and all the elements, for example, with 8 are going to appear in this reducer, and so on and so forth. That's something important because this information is not going to be separated, and then we can just process and count the frequencies of all the keys in order to get the final output of the program. Okay, so basically we're going to process, we're going to send this information to the reducers, the reducers, so for example, it's coming here, brown, fox, and so on and so forth. And then your reduce program is going to take this as an input, and it's just going to aggregate this information to get the final output. And then we have the final output of my MapReduce program. Remember, it's quite simple. We have the input file is going to be just a set of blocks. We're going to have one mapper, which is exactly the same program that is going to be running in parallel in different nodes. And that mapper is going to be generating key values. In this particular case, we have that the key values are going to be the word and one, the second word, and so on and so forth. That really depends on your particular application. If you need to do something else, you have to implement this in a different way, but you need to follow this structure. Okay, the input for the mapper is going to be one block, which is at the end one file. We generate key values, we send that information to the reducers, and then the reducers are going to aggregate that, and they will be generating the final output. This is what is happening inside. Okay, we don't really need to know all the details, but it's important to get a general idea. Okay, all the mappers are going to get the information, and then they start computing all the key values, and then they are going to forward that information for the reducers. And then the reducers are going to, these are files. Okay, so basically the mappers are going to, the input is going to be for each particular mapper, the input is going to be one file, and the output is going to be one file or one block of a file, let's say in that better way, because we are talking about the Hadoop distributed file system. And then the reducers are going to be taking that file, which is the output of the mappers, They're going to be appearing in increasing order, and then we can process that, aggregate that information, and generate the output file. Okay, so that's the key point of the MapReduce framework.